Hello, so today we will talk about linear regression and ANOVA assumptions and limitations. As we've previously talked about linear regression assumptions, some of those include linearity, homoscedasticity, which is equivariance, and multicollinearity, which is a high correlation amongst variables. We also have some assumptions and limitations in ANOVA as well. Independence, so that the variables are independent of each other. Homoscedasticity for this as well. And one of the limitations is the ability for an ANOVA to detect differences, but not relationships. So we're going to continue looking at some subscription plans and the satisfaction scores across those plans. So I generated that. But this particular time, we're going to check for normality as well as homoscedasticity. We're going to use that Shapiro-Wilks test and the Levine's test for equivariance. So looking at the Shapiro-Wilks test for each of those product types or subscription levels, they all are less than the significance level of 0.05. So we have some non-normal data sets here. The Levine's test for equivariance is greater than 0.05, so it does show equivariance across those product levels. Because we have non-normal distribution amongst these data sets, we're going to use a non-parametric test. So we will not just use a one-way ANOVA. We will use what's called the Kruskal-Wallis test. And we'll use a box plot for the visualization of that as well. So when we use that Kruskal-Wallis test, we get a p-value of much less than 0.05. So we must reject the null hypothesis that there is no difference, because there is actually shown to be significant difference in the satisfaction scores across the subscription plans. As we look at the box plot, here we can see that we're looking at the means of these, and there does seem to be, just from the naked eye, some difference of the mean. There's no overlap, so we obviously know that the means are different, but based on the Kruskal-Wallis test, there is significant statistical difference in those means. And I mentioned one of the limitations of ANOVA is it can tell you, it can detect differences, but it can't give you the relationship. So with that, you must pair it with a post hoc test. So I am using Tukey's. And as we use that and get the table from Tukey's, looking at basic and premium, the p-value is less than 0.05. Basic and standard is less than 0.05, and premium and standard is less than 0.05. So it looks as though we must reject the null hypothesis on all of these. And as we see here in our little cheat column, that is true. We must reject all of these. So there is a significant difference of mean across all three subscription levels. So that's how you would use a post hoc test alongside an ANOVA test.